Hello everyone. Today we'll start chapter number 15, Some Natural Phenomena, part 1. The topics which we'll cover are lightning, electric charges, charging an object, interaction of electric charges, the story of lightning. Now in your previous classes you have studied about that what are winds, storms, cyclones, rain, thunder. So in this chapter our focus is on electric charges in the context of lightning. Okay, lightning is a natural phenomena. Now in winters we wear woolen clothes. Okay, so when we take off our woolen clothes or nylon clothes, we see a spark of light in the dark. Or sometimes when a plug is loose in its socket, then again we see a spark of light. This is electric spark, that is electric discharge. So in rainy season we see a light in the sky, that is again an electric discharge, and that phenomena is known as lightning. So we can say that lightning is an electric discharge but on a very large scale. So to know that how it happens, how lightning takes place, we should first know about what are electric charges. You know that universe, it is made up of matter, and matter, the smallest unit is atom. You know that atom is the smallest unit. Then in an atom there are proton, neutron and electron, out of which proton is a positively charged particle, whereas electron, it is a negatively charged particle. So in a stable atom, number of protons is equal to number of electrons. Okay, I'm sure that you have performed this activity. Okay, in this what we do, we rub balloon against our hair, and what we see that this balloon attracts our hair, or the balloon gets attracted, means the balloon gets stick to the wall or any other substance. So why that happens? Look, this balloon is also a matter. It contains millions of atoms, and in an atom protons and electrons are present. So what we actually are doing, when we rub this balloon against our hair, we are transferring charges. That means we are disturbing the number of electrons in an atom. Let's say this is any object and this is a balloon. So when we rub, so you can see there is an arrow by which we are showing that there is transfer of electrons, that means negatively charged particle. So after rubbing, this balloon is negatively charged object because it has more number of electrons. So this is transfer of charge from one object to another object. The object losing negative charges has a greater number of positive charges or becomes positively charged. The object receiving negative charge becomes negatively charged. By this what we mean, always remember there is transfer of electrons. Okay, the protons are untouched. This is our balloon, and let's say this is any girl. So when she will rub this balloon against her hair, what she is doing, the electrons, let's say initially 2 protons, let's say 3 protons and 3 electrons are there, and in this balloon also 3 protons and 3 electrons. So after rubbing, the electrons of this girl are getting transferred on this balloon. Now she has 2 electrons, but this balloon has now 4 electrons. Now this balloon has more number of electrons than protons, that's why we call that this balloon is negatively charged. Whereas now this girl has more number of protons as compared to electrons, so we say that this girl have now become positively charged body, the hair. So here what we are saying that there is loss of electron on this girl and there is gain of electrons. And here loss of electrons. So overall we always talk about electrons. Either there is loss of electrons or there is gain of electron. In a series of simple experiments, it was found that there are two kinds of electric charges which are given the names positive and negative by Benjamin Franklin. This is a scientist. He suggested two charges. He suggested the name positive and negative charges. There are two types of charges, positive and negative. Positive is proton, negative electron. Now charging an object. Initially the object is uncharged. Uncharged means the number of protons are equal to number of electrons. But how can we make that object a charged object? We can do that by rubbing. Charging by rubbing. Rubbing or friction. You can see here it is amber, glass rod, comb. So when we rub all these objects with any cloth material, either it can be wool or fur, then the object gets charged. Why? Because by rubbing we are transferring charges. This is the very common example. If you use plastic comb for combing your hair, if you will bring that comb near the piece of paper, so that comb will attract those piece of paper. Why? Because when we are combing our hair, then that plastic comb is getting charged by the friction, by rubbing, and that is why that comb is able to attract these piece of paper. The next topic is interaction of electric charges. For this, we'll see a simple activity. In this, we are taking ebonite rod and we have hung it with the help of thread. Now we will rub this rod with wool. Okay. So what is our purpose? Why we are rubbing this ebonite rod? To make it a charged body. Similarly, we will take another ebonite rod. Again we will rub it with the woolen cloth. Again this body is getting charged. Now when we will bring this rod, ebonite rod, near to this rod, then you can see that there is repulsion. Okay, there is separation between these rods. This is repulsion. Okay, this is one activity. Then in second, we have taken glass rods. One glass rod is attached to this stand with the help of thread, and we have rubbed this glass rod with the silk cloth. Again the same purpose. By rubbing we are making it a charged body. Similarly, we will rub this glass rod with the help of silk cloth, and again we are making this glass rod a charged body. Now when we will bring this glass rod near this rod, then again we will see the same. There will be repulsion between these two glass rods. Okay, this was our second activity. Now in third, what is happening? This glass rod is a charged body, and this ebonite rod we have taken from the activity 1. This is again a charged body. Now when we will bring these rods together near to each other, then they will attract. You can see there is the point of contact between these two rods. So this is attraction between these two rods. In first experiment, we were rubbing it with wool and there was repulsion. Activity 2, we were rubbing these rods with silk cloth and again they were repelling each other. But in this case, they both were there were force of attraction. So by this, we can conclude that these rods were having same kind of charges and these rods, glass rods, were having same type of charges. But when the opposite charges bring together, there were force of attraction. So we can say that like charges always repel each other, as in these two cases there were like charges, and unlike charges always attract each other. That means opposite charges always attract each other and same charges always repel each other. So it has been observed that two charged objects having the like charges repel each other, while the two charged objects having unlike charges attract each other. The electrical charges generated by rubbing are static. Look, when we are making that body a charged body, then there are electric charges, but those charges are at rest. That means those charges are not moving, and that type of electricity is known as static electricity. As in your previous class you have studied about electric current. That is the same. But in that, how do we define electric current? Flow of charges. That means charges are in motion. That was electric current. Current means a flow. But here this type of electricity is known as static electricity. Why? Because charges are at rest, they are not moving. That electricity is known as static electricity. The next topic, transfer of charges. Here we have taken two metal sphere, one is charged and the other one is neutral, that means uncharged. But now in this case we have taken an iron nail which is a conductor, good conductor. So when the one end of this nail is touched to the charged body and the another end of this nail is touched to the neutral body, then you can see there is transfer of charges from a charged body to an uncharged body. You can see plus plus sign, that means the charges of this body are being transferred to the uncharged body, and after this transfer this body has also become now a charged body. So by this we can say that charges can be transferred from one body to the another body. Now in some cases we don't know that whether a body is charged or not. So to find out that whether a body is charged or uncharged, we use a device known as electroscope. It is a device used for detecting and measuring charges of small magnitude. We'll study gold leaf electroscope. What we need a glass jar and a metal disc. This is the metal which we are using is brass. So this metal disc, that means brass disc, and this brass rod, at the end gold leaves, two gold leaves are used. That's why we call this type of electroscope as gold leaf electroscope, and a cork to fit this rod. Now what we will do, we will bring a body near this electroscope. Now we don't know that whether this body is charged or uncharged. Now when we will touch this rod with this metal disc, if this body is charged, then there will be transfer of charges from this rod to this metal disc, and through this metal disc and brass rod, it will transfer to the gold leaves. Now these leaves will carry similar type of charges. If this body is positively charged, then these leaves will also be, they will also get positive charge, and we have discussed that like charges always repel each other. So we can see that these two gold leaves separate out. There is separation between these two leaves. So by this activity we can say that it is confirmed that this glass rod is a charged body. Understood how we are detecting whether a body is charged or not? And if this body is uncharged, then there will be no transfer of charges, and it will remain the same like this way. Okay, there will be no divergence. Now after making this electroscope a charged electroscope, if you will touch this metal disc, then what will happen? This electroscope will come to its original state. And why is that happening? Look, it will come to its original state because your body is also a conductor. So those charges through your body flow towards the earth. They are sent to the earth, and that is known as earthing. So earthing is the process of transferring of charge from a charged object to the earth. So in all cases we cannot stand and we will not touch any metallic object to transfer those charges to the earth. So in that case we use a wire. If you have heard of earthing wire, in a socket there are three wires. One is connected to positive terminal, another is connected to the negative terminal, and there is one thick wire which is earthing wire, because electric current flows in our circuit, in our house circuit. So there are very few free charges which by which we might get shock. So to avoid that situation, we add earthing wire in our socket. And what is the role of that earthing wire? It transfers the free charges to the ground, to the earth, and that process is known as earthing. Here you can see this is earthing wire which is going to the earth. So this wire will carry all those charges. Now the story of lightning. We all have heard thunder and seen lightning in the sky during the rainy season. Lightning usually takes place with thunderstorms with a loud sound. You all are familiar with this fact, with this phenomena. This is lightning. We see light up above the sky during rainy season only. So why that happens? What is the reason behind lightning? Look, in rainy season, clouds are formed. Okay. Now in the atmosphere, air particles, dust particles are also present. So when those clouds are rubbed with those dust particle, air particles, then those clouds get electrically charged. Okay, because we have discussed that by rubbing we can make any object a charged object. So similarly here, clouds are also getting electrically charged. So in a cloud, the negative charges settled at the lower portion and the positive charges are present in the upper portion of cloud. Now, because of the negative charges in the lower portion, there is accumulation of positive charges on the earth. And we know that opposite charges always attract. So, and between the cloud and this ground, air is present. And we know that air is an insulator. So, normally, there is no attraction between this negative and positive charge on the ground because air acts as an insulator. But if the amount of these charges are very huge, if the amount is very huge, then this air which is present between cloud and ground, it cannot resist the flow of charges. So there is flow of charge between negative and positive charges, and that flow of charge constitute what? Electric current, electricity, and that's how we see that lightning, that spark of light, that is what? Electric current, because of the flow of charges between clouds and the ground. It is not only between cloud and ground, it can be between two clouds also. Okay, so rapid flow of charge through the air between the two oppositely charged clouds is called electric discharge or lightning. Is this clear what is lightning and how it is generated? Then the lightning is so dangerous that if a person happens to be near the location where the lightning falls, he may be severely burnt or even killed. Yes, we know that electric current is very dangerous for us. Here you can see, not only for us, for all living organisms, for animals too. It can cause the building fire. Then safety measures during lightning. What precautions you should take during lightning? These are outdoor precautions. First, if you are outside, then go inside your home because it will be safer. Then if you are in a car, in a closed vehicle, then shut your windows and doors. Or if you are present in an open field, then do not lie on the ground, sit in this position. And unplug all your devices because it can damage your appliances and it can cause fire also, lightning. And you should not stand under a tree. Why? Under a tall tree. Why? Because lightning always look for an easiest path. Okay, the tall buildings, tall trees, they are the easy path for the lightning, and lightning can reach to the ground with the help of tall objects easily. So that's why if you are standing under a tall tree, then there are chances that lightning can strike on this tree and this tree will get burned and it can damage you, it can harm you. Okay, the next topic is lightning conductors. Lightning conductor is a device used to protect buildings from the effect of lightning. As we know that so many tall buildings are present, and we also know that lightning always looks for an easiest path. So this tall building gives an easy path to our lightning. So to protect our building, what we use a device known as lightning conductor. It is a metallic rod which runs from top to the bottom of the building, and bottom end of this rod is connected to a metallic plate. Here you can see we have used copper plate, and this plate is buried inside the earth. So whenever lightning falls on this building, with the help of this metallic rod, all those charges flows from top to the bottom of our building and to the copper plate. And this is the purpose of lightning conductor, to save our building. So the people who are living inside this building, they are protected from the effect of lightning. So here comes your next internal question, which you have to write on page 199. What is lightning conductor? And mark the answer. Lightning conductor is a device used to protect buildings from the effect of lightning. And there is one more internal question. 197. What is earthing? Earthing is the process of transferring of charge from a charged object to the earth. So that was all about the part 1 of this chapter. Thank you.